Every day's a party in physics class. Here we go. So what are we going to do next? We're going to do forces, frictions, and accelerations. Oh my. But no bears, lions, and tigers. So we're good. All right, piece of cake. So here we're going. The first part of the formula is pretty basic. Okay, we're using the net force equals mass times acceleration formula. Or you could use it as acceleration is equal to force divided by mass. It's the same formula. Basically, you're just plugging in the ones you know. In this case, net force is equal to the mass, 2 times the acceleration. Well, 10 is equal to 2 times 5. All right. Now, you do need to put units. I did not do that, but you will need to do that. All right. So make sure when you click on here that you do put 5 meters per second squared, or you can do meters per second, which is the same thing, which means that you're going 5 meters per second faster every second. All right? And you would just do this and solve for whatever is missing in each of these, okay? This one is just asking if you understand the formula. If net force is doubled, the mass stays the same, what happens to acceleration? Now, you can look at the examples, but really, I would say just do this. Look at the formula, which is this. Acceleration equals to force, net force, divided by mass, okay? Now, if you do that, very simple here. The number on top, force, I didn't put an equal sign in there. Let me try that again. Okay, boom, there we go. Okay. Acceleration equals mass of force divided by mass. If the net force is double, it's on top. So it's going to directly change and be directly proportional to the acceleration. All right. So if it doubles, guess what's going to happen to the acceleration? The same thing. All right. If the net force is half, then what's going to happen to the acceleration? Same thing. And then this tells you that there is what kind of relationship between net force and acceleration. All right. Down here, we're talking about mass. Well, mass is on the bottom, so it's going to be an inverse relationship. Okay. And so if it doubles it, what will it do? Well, you can look at the examples and kind of figure that out for yourself. Now, these other problems down here, just you're going to plug these numbers into the formulas to figure out what the answer is, and that's pretty straightforward. Now, when we get to the free body diagrams here with the friction ones, that's going to be a little different, okay? Based on the information they've given you on this free body, in this case, they've given you the force of friction, which is pushing against it this way. The applied force, or how much you're pulling on it, which is going that direction. So F app does not mean that you need to download the Force app. I know, don't panic. I know you're probably looking in the Google Play or the App Store or whatever, but don't worry, it's not there, Apple Store or whatever. And yeah, there is no app for this. Okay, this is the force that is being applied to it, so it's being pulled this direction. So if we know the force of friction is this much, force of being applied is this much, it is definitely going to be speeding up and to the right, okay? So we know there will be an acceleration, should be a positive number. All right. Now, we need to find all these other values. All right. Now, to do that, we can look at some formulas. The force of gravity, in other words, how much gravity is pulling on you, is equal to your mass times g, which is 9.8 meters per second squared. G, little g, is equal to 9.8 meters per second squared. All right. Now, I'm sorry, I didn't say G minus. Sorry, that should be G equals. All right. G equals 9.8 meters per second squared. So first of all, this one is a good formula because if you know the mass or the force of gravity, you always know what G is equal to. Notice this is not the force of gravity. This is acceleration due to gravity. The acceleration due to gravity is 9.8 meters per second squared. All right. In other words, every second it goes 9.8 meters per second faster. All right, which is about 20 miles per hour. So it's speeding up pretty quick there. All right. Anyhow, so since you know G, if you know one of these other ones, and we do in this case, we know force of gravity, for example, you could plug that in and solve for M, the mass. Okay. Now, the force of friction, or frictional force, all right, is the force of friction equals normal force times the coefficient of friction, or here it's the coefficient of friction times the normal force, same difference either way. Okay, so if you know two of those, you can solve for whichever one you're missing there. Now, the normal force is nice because the normal force is where the surface is pushing up and these are down. Now, all of these are sitting on the counter or on a surface, so they are not going up or down. So that means the force of gravity pushing down has to be equal to the normal force pushing back up. And so for our purposes, as long as we're sitting on a surface, these two are going to be equal to each other. Okay? And once again, there's G. G is equal to 9.8 meters per second squared. Okay, I guess I gave it to you anyhow. But it's a good thing to know anyhow. If you wrote it down, it's good for you. All right. So let's see what we can solve. Well, first of all, we know that if this is 83.2, then we know this up here must be 83.2 newtons. Don't forget to put your newtons on it. All right, 83.2 newtons. So we know those two are the same. All right, now, in order to find the mass, we can plug in, we said the force of gravity, which we know is 83.2 newtons. Okay, we know the force of gravity is equal to 83.2 newtons. It's equal to the mass, which we don't know, times the next one, which is the 9.8 meters per second squared. So there we go. Now, once you have that, then you could solve, divide both sides by 9.8 meters per second squared, and that would give you the mass, okay? Now, all right, so once you divided the one we just did up there, you should have ended up with 8.49 kilograms, okay? Now, just for the purposes of canceling things, we need to know that kilograms, when it comes to newtons are equal to kilograms times meters per second. Meters per second squared. All right. Oh, I'm not sure why that went up there, but anyhow, it should be meters per second squared here. So when you cancel that, when you had the newtons divided by meters per second squared, that would give you 9.8 meters per second squared. That would give your units would be kilograms. Okay, it should be a little k, a little g, such as that. Okay, so that gives you that one. Now, to find, we got the normal force, we got the mass. Okay, we have the applied force, which would be this. To do the next thing, though, we need to find the net force. Well, we don't have an actual formula that we listed that you could check for that. But just like on the worksheet we did the other day, if these two forces cancel each other out, so there's no horizontal up or down movement. There's only horizontal movement. Well, this is the force you applied, and here's the friction force going the opposite direction. So if you just take those two forces and subtract them, that will give you the net force. Okay, and that's what we did before. So 55.6 minus 15.1, and those are both newtons, is going to be equal to your net force. And in this case, if you subtract those two, you should get 40.5. Oops. And for some reason it's not writing. Don't ask me what's going on here. Okay. So let me try that again. For some reason I'm on comment, not text box. Let me fix that. Okay. And it is 40.5 newtons, okay, as your net force. Okay. Now that we have mass and we have the net force, we could find the acceleration using this net force equals mass times acceleration formula. Okay. And that would probably be the best thing to do here. So we would do that. Actually, since we're finding acceleration, I would just use the formula that says A equals F divided by M. Okay. And so if we do that, we would know that it's equal to 40.5 newtons divided by the mass, which is 8.49 kilograms. Now, remembering that newtons is equal to kilograms times meters per second, we would divide by kilograms. That's going to get rid of that, and our answer will be in meters per second, which is what acceleration is measured in, so that's good. And if we do 40.5 divided by 8.49, we would actually get, we would round off to 4.77 meters per second squared. All right, and that would be our answer there. Now, the only thing left that we need to find out is the coefficient of friction, and the only formula that has that is the friction force equals coefficient of friction times the normal force. So we know the friction force is 15.1 newtons, and we're saying that's equal to the coefficient of friction, which I'm just going to put an M there because I can't find the mu. I'm not sure how that works on the Mac, and I have a PC instead of a Mac. This time I know where it is on the Mac, but I don't know where it is here. Okay, so I'm just going to put CE for coefficient of friction. Okay, and that's times the normal force, which is 83.2 newtons. Okay, and so if I were to solve this, I'd divide both sides by 83.2. So 15.1 divided by 83.2 is going to be equal to the coefficient of friction. And if I do that, it's going to be usually a pretty small number because it's just a number to give an idea of how much smooth or rough a surface is. In this case, it should come out to 0.181. And the units, since you have newtons, and then you would divide by 83.2 newtons. Newtons divided by newtons cancel, and it's just a number. So a coefficient is just a number that rates how smooth the surface is. Okay, and that's a relatively smooth surface because it's a fairly small number. Closer it is to 1, the more force-like it would be. All right. So a couple things on this one. The next one, I'm not going to do it for you, but first of all, we know the force of gravity and the normal force are going to be equal, so that I'm going to do that for you. The net force could be found by subtracting those two. The coefficient of friction would be the force of friction is equal to this times the mass. So you'd have to use one of these other formulas. Probably I recommend this one to find the mass. And then once you find the mass, then you use mass and net force to find the acceleration. And then you can use friction force and the net force to find, force of friction and the normal force up here, which is the same as this, to figure out the coefficient of friction. Okay, hopefully that's not too confusing. But anyhow, give it a try. Try some more. If you have questions, then you can send me your questions.